So the next thing that we're going to get into is solving some first degree trigonometric equations. Now, realistically, you guys have probably seen the interval notation before. We're just saying right here, with the close bracket, same thing as less than or equal to, and that's the close bracket. And the open bracket just means less than. Now, in these first degree trigonometric ratios, what you'll notice is you'll see these have restricted domains, or these have special domains. So I'll sort of explain what's going on with that when I get to that point. The first thing that we want to do is we want to solve this for the sine x. So I go root 2 sine x equals 1 because I add 3 to both sides. Then I divide both sides by root 2. So I get sine x equals 1 over root 2. Okay. So you guys remember that root 1 over root 2 is the same thing as root 2 over 2. So depending on what unit circle you have printed out, you're going to see one of those two. So we look for where y is equal to 1 over root 2. Since the sign value is positive, that tells me it's going to be in the first and second quadrant. And we get the answer of 30 degrees. And the other answer that I'm going to get is 150 degrees. So we get 30 degrees and we get 150 degrees. Now, one thing, since this is asking for degrees, that means my answer is going to be in degrees and not radians. And you don't have to answer in both unless it specifically asks you to. So we need to find this in the specified domain, and my domain is negative 360 to 0. So how am I going to find the coterminal angles to this in that domain? Simple. I'm just going to go backwards one rotation. So I'm going to subtract 360, which will give me negative 330 degrees, and 150 minus 360 will give me negative 210 degrees. So these would be my two answers within that specified domain. From there, well, we want to find the general solution. My general solution always comes off the angles between 0 and 360. So it's going to be 30 degrees plus 360 degrees n, and it's going to be 150 degrees plus 360 degrees n. Now, we also do have to toss on the disclaimer that n is in the set of integers. Just so you guys know, integers you'll either see as an I or as a funky Z right there. Either one is good. The I is predominantly used in high schools, but once you get to university, it'll tend to default to the Z. Okay. So let's check out our next one. 2 sec x minus 5 equals sec x minus 3. First thing that I do is I add that 5 to both sides, and now I get 2 sec x equals sec x minus, whoops-a-doodle, plus 2. I then subtract my sec x from both sides, and I get sec x equals 2. Now sec x, as you guys remember, is 1 over cosine x. So I get 1 over cosine x equals 2, or rather that becomes cosine x equals 1 over 2. So we remember that the cosine is equal to the x value, or rather my cosine is positive, so my answers will be in quadrant 1 and 4. And right here, we're working with radians, so I need to see where the x value in quadrants 1 and 4 is equal to positive 1 over 2, and this gives me a solution of pi by 3, and the other solution that I get from this is 5 pi by 3. So since we're looking between 0 and 2 pi, this would be my two solutions. Then for the general form, it would be plus 2 pi n, again representing every rotation, and then 5 pi by 3 plus 2 pi n. And again, we have to remember that n is in the set of integers. Okay. So root 3 cot x plus 1 equals 0 for negative pi to 0. Well, right here I go root 3 cotan x plus 1 equals 0. I minus the 1 from both sides, so I get root 3 cot x equals negative 1, or I get cot x equals to negative 1 over root 3. Now remember, cosine x is equal to 1 over tan x, meaning that tan x will equal negative root 3. So now I need to figure out in what quadrant tan x is going to be equal to negative root 3. First of all, we see that it's a negative value right there. So tan is negative in quadrants 2 and 4. So looking at quadrants 2 and 4, now we also remember the tan is equal to opposite over hypotenuse. So that means it's going to be equal to y over x. So I look and I have to have the y over x, which will equal negative root 3. So looking at that, we need root 3 over 2 divided by 1 over 2, or y divided by x, and the solutions it would give me would be x equals 2 pi by 3, and x equals 4 pi. Sorry, quadrant 4, or x equals 5 pi by 3. So I get my solutions from quadrants 2 and 4. Now, the next thing here is we notice the negative pi to 0. So my solution has to be between negative pi and 0. Since this one is in quadrant 2, that's not going to fit into that domain. So we look at this one, which was in quadrant 4, and then I go 5 pi by 3. I subtract the 2 pi from it, or the 6 pi by 3, and this will give me negative pi by 3. So negative pi by 3 becomes my answer for this equation. Now, when we unrestrict the domain, I have to actually look at both solutions again. So my general is going to be the 2 pi by 3 and the 5 pi by 3. Now, what's interesting about this for tan is all that we'd have to do is we'd add pi n to this. Or we'd add, that pi n, because we said that the period of tan is equal to pi, or repeats itself every pi. But from there, you guys that are astute may notice that 2 pi over 3 plus pi actually equals 5 pi over 3. So I don't have to keep on restating my solutions. So the only solution right here would be that 2 pi by 3 plus pi n, because the 5 pi by 3 is included within this initial statement. So it would just be restating ourselves if we had that right there. I hope you guys have enjoyed, and the next one we're going to get to is solving slightly harder equations.